Hi, I'm Vaibhav Gopal and I will be presenting my final project proposal on GIS-based analysis spatial patterns for vehicle crashes in San Jose, California. According to traffic situation, San Jose is the third most dangerous city in California, and the evidence that supports that estimate found that only 3% of San Jose's streets are home to 50 fatal traffic accidents, and it is crucial to comprehend spatial patterns and explore the causes underlying those patterns for decision makers, city planners, and general public. And here is a map that represents that. My research question is what relationship exists between the speeding crash locations, and the road segments? What types of roads are prone to speed crashes? And its objective is the connection between the locations of road segments and crashes involving speed. And the study is the connection between speeding crashes and the state of the roads, whether it's wet or dry. And its significance of the research question is the data from 2020 to 2022, known as the COVID-19 years, is used to study collisions and give a more complex knowledge of the traffic safety situation in San Jose. The most hazardous road stretch in the city of San Jose will be communicated using maps through the search, and the speeding crashes and the road surface conditions will be better understood with the aid of descriptive statistics, which will analyze additional data to illustrate this wide range of crash data. The data that I'm planning to use is the GIS knowledge that I have got from this class, which is vector data, spatial data, buffer, scent voice, color hue, color saturation, etc. The variables description that it is speeding, lightning, road surface, condition, and San Jose city boundary. The data sources that I will be getting is from San Jose GIS Open Data Portal, except for San Jose City Boundary, which is ESI, which stands for the ArcGIS website. The steps that I'm going to take to complete the final project is identify variables, which is speeding and road conditions, and source of factors contributing to increasing vehicle speed, crashes in the city of San Jose, and the step 2 is the data collection and preparation. This is the data source, is the San Jose GIS Open Data Portal, which maps out the GIS San Jose crash locations and the streets, and and the boundary. It will be municipal boundary, which is the buffer only within San Jose. In order to do that, I have to clean the filtering by preventing to have too many data sets in my project. So, and the step 3 is geoprocessing process, which is the word buffer, and I'm planning to use 10 feet on each side approximately and dissolve. And I'm going to specially join the table and summarize how many crashes in each road segments are there, and produce the final map and dashboards with sources, some biology and presentation, and make some relationship maps between the variables that I'm going to be using from step 1. The expected result is showing the major segments that are prone to crash, and it is producing the relationship between both segments and the variables from step 1, which is roads and which is damage and speed. The map 1 shows the transportation into a mapping system, and roads showing more buffer will have higher accidents and fatal crashes, and map 2 shows a relationship between the transit stops in Los Angeles, California. So, as the number of minority population increase, the the map's wait time between 4 to 6 p.m. rush hour will also increase. The expected results is the hypothesis is the road segments that have the most speeding crashes, as the road surface is wetter, the more speeding crashes it will occur, and the drier the road surface, the less speeding crashes it will occur. And to display places and pinpoint street segments that are vulnerable to collisions because of speeding, a straightforward buffer will be started utilizing the buffer. And the other map products will also contain certain patterns illustrate the connection between distance score and damage score, showing that the faster individuals move, the higher the likelihood to be involved in a vehicle accident, and if the slower the cars go, the lower likelihood they will get into an accident. And this map will source the relationship that I'm going to be created to visualize, and compare two patterns within a single map and sort the relationship between travel distance and speed using their bivariate chloroplet mapping function and a proportional point symbol. This research expects the statistics results to sort whether the war surface will, will lead to more speeding crashes, and there are other possibilities that I'm going to add on. Thank you for my presentation. I hope you like my presentation, and thank you and have a good evening.